Okay, screencast number 2. This is probably the most important screencast of the unit. In this screencast, we're going to be doing very similar things that we did with perfect competition. We're going to be going through the decision-making process for a monopoly, how it picks its price, quantity, how it knows whether it's making a profit or not, and what things look like graphically for a monopoly. It's a pretty long handout because it's got a lot of graphs in it, but I don't think the screencast will be as long as the handout indicates. Anyway, let's get started. Alright, so the decision process for a monopolist is pretty much the same as it is for a perfect competitor. It's got to answer the same questions. Should I produce or should I just shut down, go out of business? If I should produce, what price should I charge? What quantity should I produce? And will I make a profit or loss, and how much? Alright, so let's still deal with the first question. Should I produce or just shut down? Now, fortunately, the answer here is exactly the same as it was for a perfect competitor. You should stay in business if you're a monopolist as long as one of two things is true. If you're making an economic profit, or if you're making an economic loss, as long as you're at least covering a part of your fixed costs. Just like with perfect competition, if price is greater than average variable costs, it means that you're covering parts of your fixed costs and you should stay in business. So those rules haven't really changed. The other three questions, what price should I charge, what quantity should I produce, and will I make a profit or not, are pretty similar to the way the perfect competitor operated, but it's slightly different. So what I'm going to offer you is a different step-by-step guide. Now I gave you one of these for a perfect competition. I'm going to give you the same one or the same thing for a monopolist. I'm not going to go through all the steps here now, but I want you to just point out that the monopolist step-by-step guide is pretty similar to the perfect competition one with a couple minor variations, and I put those minor variations in purple. So we'll be referring back to this guide as we go, and I'll take them step by step. Along the way, we're going to also use the same exact profit and loss rules that we use for perfect competition. When we compare price to average total cost and average variable cost, the rules haven't changed, and again, I'll incorporate those back as we go. Alright, so let's take an example. We'll start off with a clean graph, and we'll start incorporating some of the curves that we need in order to make these decisions for the monopolist. In the last screencast, we saw that the monopolist faces the industry demand curve, normal downward sloping demand curve. We also saw that marginal revenue was a curve that lies below the demand curve, and if you've forgotten why that was, you might want to go back to the last screencast and just refresh that for yourself. And then we're going to add in the same kind of cost curves that we added in for perfect competition. You remember what they look like? Right, those cost curves. So we're going to throw those into the mix. Specifically, the three important cost curves that we spent so much time back on in unit number 3. So those were marginal cost, average total cost, and average variable cost. And all the same things are true. Marginal cost is still acting like a magnet to those curves, so marginal cost is still breaking through those two curves at their very lowest points. Marginal cost still goes down, but then back up because of diminishing marginal returns, and etc. Alright, so let's start going through the steps. Using that step-by-step guide. Step number 1. Use the profit maximizing rule, MR is equal to MC, to find the profit maximizing quantity. In the graph, what that means is going to the intersection of marginal revenue and marginal cost. So we have the same exact profit maximizing rule as the perfect competitor did. Go to where MR is equal to MC. The only difference here is that MR looks a little bit different than it did in perfect competition. So following that step, again, here's the marginal cost curve, here's our marginal revenue curve, here's where they intersect. I'm going to put a dot right there. Alright, step number 2. Draw a straight line up and down from that dot. This is your reference line because what we care about is average total cost and average variable cost at that quantity. So just like we did in perfect competition, we're going to draw a little vertical line, call that a reference line. Now here's where the steps kind of change from perfect competition. Where that line hits the quantity axis, that's Q star. That's the profit maximizing quantity. That isn't different from perfect competition. That's what we did. But what is different from perfect competition, and the big different step in a monopoly, is this next step, step 2B. Follow the line up to where it hits the demand curve, and that's the profit maximizing price. Now think about what's going on here. What the monopolist is trying to do is maximize its profits. Now at this quantity, if it was nice, it could just go over to the price axis and charge this relatively low price. But the monopolist isn't nice. Monopolists are evil, and they want to make as much money as they can. The demand curve tells them exactly what price they can charge to sell different quantities. So the monopolist knows that it wants to sell this quantity. What it's going to do is go up to the demand curve, and that's how it's going to choose its price. Right there. That's the price that the monopolist is going to charge. It's charging the highest price that people are willing to pay to produce that quantity. Now, it's not charging the highest conceivable price. It's not charging a price like up here. Up here, somebody's willing to buy it. It's charging the price that corresponds to the profit maximizing quantity at the profit maximizing output. All right, moving along. Step 3, find where your vertical line crosses the average total cost curve and the average variable cost curve. That's average total cost and average variable cost at the profit maximizing quantity. And just like in perfect competition, we're going to make another couple dots. Right there, that's average total cost. And right there, that's average variable cost. Again, we're using that reference line and finding where that reference line crosses those curves to find ATC and ABC at Q star. Steps 4 and 5. Compare the price at Q star to both average total cost and average variable cost, and apply the same profit and loss rules that we saw before, specifically these profit and loss rules. Now in this graph, you'll notice that the price is greater than average total cost, which means the same thing it meant in perfect competition. This is a firm that's making a profit. Again, here's what it looks like. Here's where price is at about $40. Here's what average total cost is at this quantity at about $30. And again, you can calculate the amount of profit or loss per unit and total profit and loss just like we did back in perfect competition. The formula for profit or loss per unit is price minus average total cost. Or in this example, $40 minus $30, which is equal to $10. This monopolist is making $10 per unit for every unit that it sells. Graphically, it'll look the same as it did in perfect competition. The vertical distance between price and average total cost. That vertical green line is $10 big. Also, just like in perfect competition, we can figure out the total profit or loss. Total profit or loss is equal to the unit profit or loss, price minus average total cost, times the quantity that they produce. So they're making $10 per unit that they sell, and notice that here they're selling 100 units. $10 times 100 units is $1,000 in total profit. Or graphically, again, it's going to look like a rectangle, just like it did in perfect competition. Here's the $10 per unit right there, multiplied times the 100 units that it sells. So this would be a happy monopolist, right? Making an economic profit, and actually there's no long-run story like there was in perfect competition. Those barriers to entry are keeping other firms out, so that whole long-run story that gets rid of economic profits in the long run in perfect competition just doesn't exist for a monopoly. This monopoly can sit with this profit pretty much forever, which is pretty sweet. I swear that's not alcoholic. All right, so that was a happy monopolist. What about a sad monopolist? Again, let's start with the demand curve, marginal revenue curve, marginal cost curve, average total cost and average variable cost, but now notice that I put those two curves in slightly different places. Okay, again, let's go through the steps. Step number 1, MR is equal to the MC rule, put a dot where that's true. Step number 2, draw your reference line. Step number 2A, where that reference line hits the quantity axis, that's the profit maximizing quantity. Step 2B, go up to the demand curve, and that's the little step that students mess up on AP exams and elsewhere. Go up to the demand curve to choose the price. Step 3, find average total cost and average variable cost at that quantity, the two yellow dots. Step 4, compare price to both average total cost and average variable cost and use the profit or loss rules. Now here, notice that price right there is less than average total cost, so I know it's making a loss. But it's still greater than average variable cost. So just like in perfect competition, this is a monopoly that's making a loss, but shouldn't shut down in the short run because it's covering a part of its fixed costs. To figure out the amount of profit or loss, again, we use the formulas. Profit or loss per unit is equal to price minus average total cost. Here the price is $40. Average total cost is $55. That's giving us a loss per unit, this vertical red line, of $15. And again, if we multiply that loss per unit times the quantity of units that it's selling, 100 units, it's losing $15 per unit. It's selling 100 of them, it's losing a total of $1,500. This red rectangle would represent a rectangle of sadness, a sad monopolist, a monopolist that's losing money but won't shut down, at least not yet. Alright, well you can kind of guess where we're going. We looked at a happy monopolist, we looked at a sad monopolist, now we're going to look at a suicidal monopolist. Starting over again, demand and marginal revenue. Here's our three cost curves, but again, this time I kind of shifted those cost curves up to show you what a suicidal monopolist is going to look like. And again, going through the steps, MR is equal to MC, place a dot. Second step, draw your reference line. Step 2A, follow that reference line down to the quantity axis, find your profit maximizing quantity. Step 2B, go up to the demand curve to find the profit maximizing price. Step 3, find average total cost and average variable cost at that quantity. Step number 4, compare the price to those two things. Now here notice price is less than average total cost. So I know it's making a loss, but it's also less than average variable cost. And that's going to mean the same thing here as it did in perfect competition. If price is less than average variable cost, it is time to shut down. Monopolists can shut down. Just because you're a monopolist doesn't mean you're going to be profitable. I mean, I could be the only one selling this particular cup, right? But if nobody wants to buy this cup, or if it's a pretty crappy cup, doesn't mean I'm going to make any money. All right. Probably want to go through that screencast maybe one more time, just make sure you caught everything. And a couple of things I want you to notice before you go on. First off, monopolists again don't charge the highest conceivable price that any person would be willing to pay. It charges the profit maximizing price, the price up at the demand curve from the profit maximizing quantity. Secondly, monopolists can make losses and they can even shut down. And then finally, you'll notice that there's really no clear supply curve for a monopolist. Unlike a supply curve in a perfectly competitive industry, there's no one-to-one relationship between price and quantity. Because the monopolist is doing this funky little thing of going to its profit maximizing quantity and then jumping up to the demand curve to find its price, there's no real clear relationship between price and quantity for a monopolist. There's no real clear supply curve for a monopolist. All right, that's it for this one. And again, I'll see you next time.
My daughter is really something else, man. She runs the house. She runs the whole house. She decides everything. Like we were playing hide and seek the other day. We play hide and seek, and we play by her rules that she invented. And do you know why? Because she sucks at hide and seek. When it's my turn to hide, she tells me where to hide. She tells me where. And then when she hides, this is her hiding. She goes over to a wall and does this. She goes, that's it. There's nothing here.